So this is going to be an explanation or a simplification of Niels Bohr hydrogen emission spectra experiment. A little bit of background info. If you have a light bulb, right, white light, or it's from an incandescent bulb, if you pass this through a slit and then through a prism, what you'll notice is you have all of the spectrum, right, red through violet, all right? And what we either know or some new information to us is that each of these colors represents a different wavelength or a different energy, all right? And white light is a combination of many of them. If we think about certain elements at a time, all right, this might be some new information. When electrons gain energy, what we say is that they get excited, right? So what that means is that an electron can jump from one energy level to another, all right? Can jump up there, right? That's called excitement. Now, they don't stay up there forever. When they relax and move back down, right, what happens is they release energy in the form of light. And it depends on how much energy is released, you can see different colors. So here we have mercury, neon, and helium, and visibly we can tell that they are different colors. Right. Now, Niels Bohr experimented with hydrogen, the most basic element, only has one electron. And what happened when Bohr did this similar process, right? You have this hydrogen tube, right, with energy via electricity or heat added in. He got a total of 4 lines, all right? Here's a more detailed example. These are the 4 colors that he saw, all right? Now, this tells us a couple things, all right? As we just mentioned, all right, when electrons move from a high energy to a low energy, energy is released in the form of light, right? A specific frequency and an energy value, which corresponds to a different color. Hydrogen has 4 wavelengths, all right? So an example of what happens is if an electron goes from 2 back down to 1, that might be one color. If it goes from 1 to 3 and then back down, that might be a different color. The transition from 3 to 2 or 4 to 2, right, could be a different color. Now, sometimes these are in ultraviolet, ones that we can't see, but other times they are invisible in the visible spectrum. So what this shows us is that there are multiple energy levels that hydrogen could move to, right? So the idea is, originally we have this model here, all right, with only one orbital or one place, right? If this were the case, then there wouldn't be all those different colors of light, right? Because there'd be no ability for electrons to move, right? The idea, what Bohr said, is that these electrons can exist at specific energy levels, all right? The energy increases as you go farther from the nucleus, right? But the electrons cannot exist in between, right? So the idea is that Bohr figured out that there are different levels, right, which we refer to as orbitals, although they're not simply circles like this. This is just our 2-dimension way to show it. And electrons can move from one to another, all right, when they're excited, and then move back down. So the idea is, through hydrogen, he saw different colors, which means that more than one energy level must exist.